Good afternoon. My name is Adriana Galvan. I'm the Dean of Undergraduate Education and Professor of Psychology. I want to extend a warm welcome to our UCLA research community, students, staff, faculty, alumni, and friends. Thank you all for being with us today as we kick off our third virtual Undergraduate Research Week. We're excited to have more students than ever participating in our virtual research week and are glad that we've been able to stay engaged with our research community throughout this pandemic. Today marks the start of our Undergraduate Research Week lecture series, exploring research across UCLA. We are thrilled to have alumni and faculty share their stories and provide insights in a variety of research topics, and we hope you join us throughout the week. I also hope that you will join us tomorrow for our Undergraduate Research and Creativity Showcase. Hundreds of students will gather online to share their work on student-initiated and faculty-led research and creative projects in live-streamed panels. This week is really about celebrating UCLA student research and recognizing their hard work. So we are grateful for all of our guests, our volunteers, our staff, and our community partners who are joining us this week. Your support has made this week possible. With that, I would like to thank Professor Victoria Vesna for kicking off our speaker series. We are very excited to hear about how her research brings together North and South Campus. Thank you, Professor Vesna.
Well, hello and welcome, everyone. My name is Whitney Arnold, and I am the director of the Undergraduate Research Center for the Humanities, Arts, and Social Sciences here at UCLA. And I am thrilled to kick off our Undergraduate Research Week 2022 speaker series with Professor Victoria Vesna. Professor Vesna is an artist and professor at the UCLA Department of Design Media Arts and director of the ArtSci Center at the School of the Arts, which is on North Campus, and the California Nanosystems Institute, or CNSI, which is on South Campus. Although she was trained early on as a painter at the Faculty of Fine Arts at the University of Belgrade, her curious mind took her on an exploratory path that resulted in work that can be defined as experimental creative research residing between disciplines and technologies. With her installations, she investigates how communication technologies affect collective behavior and perceptions of identity shift in relation to scientific innovation. Her work involves long-term collaborations with composers, nanoscientists, neuroscientists, evolutionary biologists, and she brings this experience to students as well. Dr. Vesna has exhibited her work in over 20 solo exhibitions, 70 group shows, and has been published in over 20 papers in the last decade. And so we are thrilled and honored to have her with us today. And with that, I'd like to welcome Dr. Vesna.
So today I would like to talk about art-science collaborations and being in between. And this is a role that I had since I was born, since I was a middle child. I was always in between. And going back to my childhood, I will also mention Nikola Tesla, who my father was obsessed with, actually. He really wanted to somehow bring Nikola Tesla into the American consciousness and was involved in putting together a monument for him at the Niagara Falls. And in the process of doing his research in New York City in the 70s, he was dragging this young child around. And as a result, I ended up with this large sense of wonder and curiosity. But I studied art from the start. So I went to High School of Art and Design, and I kept staying in art schools. And art schools just don't teach you science. And because my parents were from ex-Yugoslavia, I wasn't taught religion either. So this ended up being a blessing in disguise, because my wonder and curiosity was not, did not have the burdens of reductionism, of scientific thinking, or religious kind of framings. And it also is the reason why I ended up being so interested in the inaudible and invisible realms in our lives. And this is a quote from Nikola Tesla that ended up being something core to my work and continues to be, as you will see in a second. The next pivotal moment is after I finished my painting graduate school at the University of Belgrade in ex-Yugoslavia. I was invited by my mentor, Biljana Tomic, to the Venice Biennial. And at that point, there was in the Venice Biennale, there's different departments and also an international section for upcoming artists. And I had the luck to be there. But the point here is that the Biennale had the theme of art and science in 1986. And this just really blew my mind. I met Roy Ascott, who is an artist from England, who was experimenting with computers. And this just was incredible to me. So I started shifting my path from thinking as a painter with canvas and paint to thinking as someone who can work outside of that and into the networks and thinking about science. And then cut to another pivotal event. I got married to a nuclear physicist, and this definitely was a big collaboration that kept going and included some children. But one of the first things we did together is creating a documentary called Unfolding the Pyramid Secret Using Modern Physics. And this is where I discovered these incredible new sciences looking into something that's very mystical and amazing. So the combination of these worlds was really incredible. And when I would find out that we're bombarded with cosmic rays constantly, it just blew me away. Here's an image of the scientists at that point looking at inside the pyramids and the size of these computers. And then many years later, so we're talking about the project being in the 80s, many years later, we had this come up where they actually discovered some new chambers in the pyramids, the Japanese group, and we're still looking for it. So this intersection is also something that kept guiding me. And the project was in 1986, but I would say I'm still very much interested in mysteries and the unknown in relation to science, actual science, I should say. And that leads me to the next point, kind of pivotal point, when I was invited by Roy Ascott, who you would now remember I met at the Art Science Biennale in Venice, invited me to a PhD program that he just started at the University of Wales. And this was meant for artists who were in their mid-career, like myself. I was already a tenured professor at UC Santa Barbara, so it was very unusual to do this. But through my fascination with Buckminster Fuller and eventually finding out about the Buckminster Fullerene that was named after him, I decided to really dig deeper and really find out more about the nano world, about science, about how these worlds come together. And for instance, here's an image of buckyballs that was imaged by Dr. Jim Zebsky. And here, these are also his explanations. So I actually wrote down his explanations that scanning tunneling microscopy is about feeling. So it's beyond what we see. These are the Buckminster Fullerene molecules. They're 1 nanometer across. We're looking at probabilities. We're looking at empty space. And this is just incredible to me. And I started looking deeper into the architecture of life and the universal set of building rules that guide us. From simple compounds to complex cells, it seems like nature keeps repeating this. And this started going into my work that was going more and more online. So in the 90s, I started creating projects that were dealing with our identity online. And that identity would be related to avatars, to memes, and to structures. mostly focused through Buckminster Fuller's influence on tetrahedrons, hexagons, colors, and most importantly for me, sound waves. As an artist, I was also always interested in sound and even had a band at one point, but that's another story. This is another quote from a scientist friend who was telling me when I was interested in body in relation to nano, that reducing a human body to neutrons and protons would be as if it's a thickness of a human hair. So all of this I find pretty amazing. And it pretty much pushed all my focus and my work, apologies, all the focus in my work was pushed into the ideas of scale and balance. And I'll show you a few projects very quickly with my collaborators. So I've mentioned Dr. James Jimjewski, nanoscientist here at UCLA, also my partner. The first thing we did together was actually go further into the idea of a scanning tunneling microscopy. And these are just a few images where you can feel, oh, sorry, I apologize, I'm getting, there we go, sorry. So we were using the shadow as a scanning tunneling microscopy. If you see here my shadow, where I'm actually moving this buckyball with my shadow. And we had a large exhibition that was called Nano at the Los Angeles County Museum of the Art in 2003 that lasted for about 8 months. And here we created a number of installations. On the left, you're seeing zero wave at wave function, which is dealing with nano and buckyballs. And on the right is another piece that is working with Tibetan monks, which I'll mention in a second. So here we have this interaction of art, science, and also Tibetan monks, where I introduced the monks to Dr. Jimjewski and his lab. They came into the lab and replicated the center of the mandala. We talked and we had discussions that were philosophical and came to the idea that we all have a common goal to show how everyone and everything is interrelated. And here's a picture of the full mandala that was done in sand by the monks, and it took them a full month, and we kept recording it both in photographic, optical microscopy, and scanning electron microscopy. And what you're seeing here is an image that goes from the full photographic imagery of the mandala to the optical, and then when we go to the scanning electron, it loses color and we're just seeing structure. So this would be the surface of a grain of sand. And here's some children playing with the projection, which in the end, what I did is we projected the nanomandala going from that atomic scale, molecular scale, up to its full surface on a bed of sand. And people could actually touch it and play with it. The next thing that fascinated me with Jimjewski's lab is his research on cell sonics, where actually cells were making sound, which is amazing and still amazes me and a lot of other people. And a lot of my work continues to be about sounds, frequencies. And the first one that really delved deeply into it was also a collaboration with Dr. Jimjewski in his lab, where we looked into the blue morpho butterfly. So the blue morpho wings are actually nanotech of our eyes. That blue color is not pigment, it's really our eyes seeing different structures and understanding it as blue. And this was imaged also in his lab. So now we're seeing the cells of the blue morpho butterfly. And then they managed to figure out a way by putting a nano mirror and a laser to measure the metamorphosis from a chrysalis to a butterfly. And what was amazing is the way it moves is not gradual, but actually in bursts. And so metamorphosis happens in a burst. And if you think about major changes in society, which I immediately started relating it to, you're thinking about these major burst events, the self-organized criticality events that get us to big changes. This actually could be related to, let's say, the Wall Street market. You know, these ups and downs are generally a sense of if something's changing. And here's how the project ended up looking. We showed it first at the Integratron in the desert and had the Tesla coil. And then what happened is people got to sit in the center and listen to the sounds of metamorphosis as they're moving and seeing different projections. This happened all over the world and always in a different way. And this would be the most magnificent example, which happened at the St. John's Cathedral in Poland. This is one of the people who was sitting in the church. When one person would sit down, the entire church would light up and you would hear the sound of the butterfly metamorphosis sounds. Next one I'd like to show is a collaboration with Dr. Mark Cohen, who's a neuroscientist here at UCLA. And we started talking about the idea of brainstorming. And I started thinking about the octopus, of course, bring in the artist into the neuroscience land. And I immediately started thinking of other species. And at that time, in parallel, I was invited and commissioned to do a piece at the Pacific Wheel in Santa Monica. So you can see the octopus here. But what I also came up with is these octopus crowns so that people would go on top of the wheel. And then when they reach the top, actually see the full circle, a full view, and kind of make a wish. And what was beautiful is that most people actually wished for really world peace, for environmental, for health, for all kinds of bigger things of themselves. So a lot of it is about perspective, the larger perspective, and thinking of other species. This is how Dr. Mark and I developed it, actually. So he is incredibly creative and really willing to experiment. So here we have two people communicating non-verbally with 8 colors and 8 sounds. And here's another image also with Dr. Jędrzejewski participating, where students of mine actually from an honors class were doing the interaction with the octopus brainstorming. And this is very, very briefly how it works. I'll just scan through this, but basically you had 2 participants, you had 8-channel audios, and then a Raspberry Pi looking at alpha beta waves. And as this analysis happened, when they're out of sync, it sounds like jazz, and the colors and the sounds change. When they're in sync, it's a harmony and the color is the same. So it's quite fun and also shows a lot. We did this at a number of places, and there's also the EEG showing that it's in real time, that it's not something that's just theoretical. And then there's a project that took a solid 5 years to develop and for me to understand, honestly, was with Dr. Charles Taylor, evolutionary biologist, who had research that was NSF funded on mapping the acoustic network of birds. He's an artificial life expert, and he invited physicist Takashi Kinami from the University of Tokyo to participate. And I was in residence actually at the University of Tsukuba, working with the engineer Hiro Iwata. So together we came up with this piece, and another long story, too long for this lecture, but just to give you an idea how something that's initially really almost overwhelming to me to think about, how do you work with birdsong? I started understanding that birdsong is incredibly complex, and that even to try to imitate and mimic birdsong is very, very difficult. So we're not understanding this communication. It's not just about mating and feeding. And so what you're seeing here is a kind of top-down view at Ars Electronica, where two people are mimicking birdsong, and they have a few minutes to do it right. So they either collaborate or compete. And here's another person working at it. And then we did a whole thing in the VR that was actually quite wonderful in Japan. And we did it also as an online meditation during the pandemic. And then I went down into the realm of planktons. And this was at the invitation of Dr. Alfred Wendel, who's a chemist at the University of Vienna Angewandte, which is the applied arts school there. I was also in residence there, and I was absolutely shocked when I found out that 80% of the air we breathe is produced by planktons. So I feel a sense of urgency about this, that if planktons are in trouble, we are in trouble, of course, because this is the bottom of our food chain. And here what you're seeing is one image that is the reason why I got so amazed by these creatures. First of all, there's thousands of them. And this image, as an example, was first 3D image. So try to imagine taking a plankton that's so many millimeters and imaging it in 3D. Then the 3D imaging went to Martina Praschel, who's an animator, and she looked at the behavior and reanimated the plankton. This was for a movie that was never used, so it was handed to me, and here's what I came up with. I wanted to blow up these planktons to be as large as whales, to be as important as whales. And this person here is standing on an interactive pedestal. And if you're completely still, as he is being right now, then the plankton comes to you and you hear the sound of a whale. If you move around a lot, which most people actually do, you'll get some noise and you'll destroy the plankton. And this is really also to show that we're all implicated, but to bring in together some idea of wonder. I did many different iterations of this. This is one in Pula in Croatia, where I actually brought planktons in. I have AR versions of it. There's a video. And right now it is an exhibition at the Barbican in London, where there's a large, amazing exhibition. If anybody's there, you should go. It's called Our Time on Our Planet. So I also started meditations online. I just tried to do in every possible way a message that plankton are in trouble. And finally, the last piece I want to show, which is a collaboration with Dr. Christian Koberl, who's a geologist, was at the Museum of Natural History, where I was also in residence, and I happened to work with the most amazing meteorite collection. That's what I was invited to develop something about. And I love the meteorites, but I was really fascinated by the idea of stardust, which is 1/10 of the width of a human hair, and 7 to 100 tons of this material falls on Earth every single day. So I took these, some of these stardust micrometeorites and 3D printed them, developed the piece, took forever. But the exhibition opened one day before everything closed. So I went back to the States and started thinking of how we can do this as an online event. And here what you're seeing is actually encapsulates how collaborations work, even if it's online. And it actually was very, very great. I'll just briefly say who you're seeing here. So you have Paul Geluso, who's an expert in immersive sound from NYU in New York. There's myself. Then there's Zeynep, who was just finishing her graduate school at MFA at UCLA in Design Media Arts. Then you have John Brumley, who also is a recent graduate and attended University of Scuba, where he got his PhD. He was in San Francisco. Rhiannon Catalyst in New York singing, Ellie Yoteva doing 3D animation, Deborah also 3D animation, Anna Nacher, a sound artist, joined us from Poland. And here are two undergraduates, Ivan Adama and Clinton Manarman, who were helping with the sound. So you can see how we all came together and did these animations. And I have to say that the last one was actually quite touching because it was in December for an exhibition that of Alien Stardust that I could not attend because of the pandemic. And we did a meditation together in Russian that was called Molecular Light to Russia. It kind of gives me the chills thinking about it now because of what's going on with the world and especially that part of the world. But what I did for this is we edited in the Chelyabinsk meteorite that fell into Russia and focused just on that one. In the piece itself, we have 7 meteorites, one for each continent. And I just isolated this one, and the meditation was to throw this into Russia and throw light, and obviously it didn't work very well. But we keep trying. The message is thus knows no borders. Just briefly about the ArtSci Center, which was established in 2005. And Dr. Jimzewski is the scientific director. I've been directing the programming. We recently got a grant from the Getty Foundation to develop atmosphere of sound, sonic art in times of climate disruption that will be part of the Pacific Standard Time exhibitions. And we're starting a media and arts and medicine arts program, which I feel is really critical right now with the way the health of our bodies, different species, and our planet is going. And finally, just to end with my passion, teaching, and of course, STEAM, you're all familiar with. A lot of my students come from STEM, but STEAM would be science, technology, engineering, arts, and math. I have changed that to science, technology, ecology, arts, and mindfulness. And this is how I teach. And I'll just give you a couple of slides at the end to give you a sense how I bring in some of my own obsessions to the class and how I want the students to really get as much out of the campus as possible. So we had recently David Roy, who's a visiting professor in sculpture, talk to us about Black NASA. We had Extine Burrow, who came from University of Dallas and talked to the students about one breath outside. And then we went to the Fowler Museum and worked with Patricia Cavadit, who is a visiting artist from Colombia, Spain. And she talked to us about the Kipu as a new communication system. We went to the Meteorite Gallery and of course talked about alien stardust. And then I also have undergraduates and graduate students work on summer sessions where we offer a sci-art lab where I try to catch students really early before they come to UCLA to the campus and say, this is a beautiful playground and there's so many amazing people here. You could be sitting eating lunch next to a Nobel laureate, take advantage of it. And join our mailing list, join us, and walk back and forth between North and South. Thank you.
Thank you, Dr. Vesna, for that absolutely fascinating talk. And now let's go to some questions that we've prepared where we'd love to hear more about your work and your work with undergraduates as well. So my first question is, what are the challenges and benefits of your interdisciplinary collaborative work with art and science?
That's a question that a lot of people ask. And first of all, thank you so much for this invitation. I really feel honored, and I am very grateful for this opportunity to talk about the collaborations between art and science. And the challenges are many, actually, because universities are still in a kind of industrial mode. And the separation between North and South Campus is not only in the way it's structured, both in physical and spatial ways, but also in how we teach in our curriculum. They're not crossing over enough, and even with the efforts, it's very difficult. However, I've had enough kind of positive feelings lately, because as the kind of a silver lining, I would say, of this pandemic is that we can do this and we can communicate online. And a lot of the ideas started crossing over that are not linked to, oh, I have to go over to North Campus and it's going to take me 15 minutes each way. I don't think I have the time. So that being said, I would also encourage everyone to really look at their own creative side, whether they're in medical sciences or other sciences, and for the artists and for those in the creative realm and the humanities as well, to really learn more about science. And I don't mean just surface, but really communicate with scientists and see how creativity binds both. Ultimately, it's about friendship. When I talk to a scientist who is way out there in a very different kind of way of thinking and understanding our reality, if we're having a cup of coffee, we're humans and we're enjoying each other's company. And eventually, as humans, we start understanding each other, not only on that level, but also about our research. So the challenge really is there. It's real. It's something that I've been kind of plowing through, and I continue to, and I'm not alone. There's many, many people out there, including you, who are trying to break down these walls. But friendship and communication are the key. So it's definitely happening.
Absolutely wonderful points. Thank you. And so what advice would you give undergraduate researchers who are exploring non-traditional career paths that mix research and another discipline?
I love working with freshmen, and I do a lot of field lux because I try to catch undergraduates early and tell them, you are a UC student. Not only do you have open doors on this whole campus, but you can go to any UC and or online or on site and say, I'm a UCLA student, and the door will open to you there. So just imagine the kind of access you have right now. It's incredible. And the moment you graduate, that's it. The door is closed until you go to the next school. So use this opportunity whenever you can. And to my earlier point, make friends. Make friends from the other side of campus, whether that's south or north. This is advice that I always give. And I also do it in practice. I drag students all over campus to show them spaces that a lot of times, unfortunately, my students are seniors who go, oh my God, I've been here all this time. I never knew this existed, that existed, or that this professor is here. So do it as early as possible. That's my advice.
Wonderful. And finally, could you give us a preview of your next project?
Yes, actually, I've been fascinated, like a lot of people, with NFTs and with the crypto and blockchains and the issues around it. So as you have seen, my work is really, really focused on environmentalism. And I actually am pretty radical, thinking everybody should be thinking about our planet right now. So I try my best to do this with everything I do. And at the same time, because our lives and our work it all resides online electronically, the NFTs also offer an opportunity and blockchain, etc. But I'm on the fence. I'm on the fence still because of the environmental issues, and also because I see some of the old structures, economical structures, replicating themselves and how it's being addressed. However, I don't want to sit on that fence for too long. So I started looking into atomic structures, and particularly the atomic gold structures. and doing a project where this would become a kind of a value. And this value would be exchanged in relation to charities, to giving. And the whole system would be about how to help. And I don't know, and I can't say more because it's still in my head, but I'm doing a lot of research. I'm planning to walk over to Anderson and start asking them some questions as well. I'm talking and working with my collaborator and partner, James Szymczewski, and his student son, Lilac, who have been looking at gold atoms. And as they're looking at the nanoscale of these gold atoms, I was on the sidelines as usual going, gold and inflation and what's going on in the world now. And values. What do we value? This is really the key question that I want to address to actually create a kind of a currency. And it's a really wild idea, but I'm just plugging at it. And eventually I hope to at least raise some questions at a minimum with this project. So thank you for asking that, because it makes me gotta put it out there and commit to I have to actually do this.
Well, that is absolutely fascinating, and we really look forward to it. So thank you so much, Professor Vesna, for your fascinating talk and providing such wonderful insights for our undergraduate research community. Thank you everyone for attending this session. And after the session at 1 p.m., we will have an innovation and community student panel. And then we encourage you to attend the events throughout the rest of the week, including the continuation of our speaker series on Wednesday and the Undergraduate Research and Creativity Showcase as well, which is from 12:30 to 5 p.m. tomorrow, where over 1,300 students will present their research. So we hope to see you then, and thanks so much for joining us.